Hello everyone. So today we want to talk about one-side limit. So here's the example. So fx equal to 3x squared minus 4x plus 4. So find the one-side limit, and then we got two different questions here. Okay. Then we better understand what's the meaning of the one-side limit first. Okay. So in this question case, we want to find out the center on 2. So x move to 2 plus, x move to 2 minus. So as we just looking at the graph, and then I'm going to explain what that means. So this is the fx equal to 3x squared minus 4x plus 4 graph. So to make understand better, I'm gonna make just one of the vertical line, which is x equals 2, because this is our at the limit point basically. So I'm gonna just make a point so that we can see really clearly. Okay. So as you see, this point become 2 and a here. Good. Okay. Just to make another point. So maybe around here. Okay. So I can move in like this, right? Okay. So now I'm going to zoom in more this part only and then explain one side limit more. Okay. So I'm going to take picture only this part and then explain on the whiteboard here. So from centering on this point 2, so 2 plus means the value coming from the positive side. So so this line means actually y value. So this value going toward basically this value here. That's the basically plus side limit. So from the right side. Then 2 minus means from the left side here like this. Okay. Okay. So when you look at this graph, then we see that both graph approach to this point A, the coordinate become 2, a here, right? So in this case, we can answer just 8 and 8. Okay? Therefore, now we can also conclude that limit x move to 2 from the positive side equal to limit x move to 2 from negative side. They both are equal to a here, the exactly same value 8. So overall limit x move to 2, fx also equal to 8. Okay. All right, then look at another example. So I'm going to say gx equal to maybe 1 over x minus 2. Okay. So then this is the rational function. Then from here, can you define the domain value? Yes, domain is all real value, but x cannot be 2 here. Why? Because x equals 2, then this fraction becomes undefined. So then how do you call this line then? X equal 2 line. Yes, this is our vertical asymptote. The last time we talked about that, this vertical asymptote divide two different groups. On the left side, which means negative side, on the right side, which means positive side. So far so good? Okay. Then I'm gonna do this graph also on the program, and then we can analyze the limit one-side limit value together. Okay. So first of all, one thing is we can think about limit x move to our vertical asymptote, which means 2. So I can say 2 plus gx. Number 2, limit x move to 2 from minus of gx. Okay, then let's go to the program. Okay, so this is the graph of y equal to 1 over x minus 2. Now, I'm gonna zoom in just on the negative side first, and then we think about what is going on. So, whenever I'm moving this point, like this, now what do you have to do, what do you have to see? Look at this, please. Okay, so whenever I'm moving here, the x value approaches to 2, basically the y value moving to the negative value. Okay, it's already negative 9 here. You know what? So I'm gonna make a slider, and then we'll give you better simulation. Just to wait for me for a second. Okay, so I just made a slider, and then so I can show you the better simulation. So I just make a negative side and point A here. So look A coordinate carefully, and then I'm gonna just moving this slider. Then look Y value carefully. So whenever I'm moving more close to 2 here, so far it become 1.911, and then I can do more, a little bit dramatically. Then what happened? So look at Y value is getting much smaller. So you look at here basically, and if I really close to 2 here, then so you see that it's already negative 99.999 like that. I go a little further, so this time, yeah, it's become already negative 166. So it's getting bigger and bigger, right? So this is not conversion point, it's totally diverge point. So we cannot define them. In this case, we concluded infinity, right? But this direction become negative infinity. So now we can say from here is, so far is going toward that negative infinity. Okay, so even though we cannot define limit, but only one side we can conclude this is negative infinity. Now, what about the positive side? Okay, so I'm going to show the same simulation. Okay, so as you see, I just defined the point B on the positive side, and I just make 2.1 and then 10 here. So it is really close to already, because I'm gonna make the simulation, the value is close to the 2 with a 3 decimal digit number, which is really small. That's why I make like that. Otherwise, I need to simulate for a long time, right? So I'm gonna zoom in more so you can see some gap here, and then I'm gonna show that I'm gonna moving these two close to 2 here. Okay, so if I do, so you are looking at now this point, please. This point. Then this value keep on moving. So as you see, x value start decreasing and y value start increasing, and this going, and the y value getting bigger and bigger dramatically. And then when it approaches to almost 2, then it's already 142. Then I keep on going more and more. Then what about here? So 999. And then even, wow, this is 999,999.999 like that. So it's totally infinity. So compare this value, and then when it was exactly 2.1, we began 10. Now it end 999,999 point something. So it's going toward that with a positive direction infinity value. So now this answer we can also say infinity. Of course, they are not connecting each other. So overall, limit x move to 2 gx, no limit though, basically. Okay. So we continue more one-sided limit example from the second video. Okay. So that's all this video, and then I will see you soon.